Hello and welcome. My name's Roy. A few weeks ago I took delivery of an Arduino Uno Starter Kit, and I've been working steadily through some of the items within it over this last few weeks. You can see that the kit itself is very comprehensive. It contains things like RFID sensors, it contains light emitting diodes and servo motors, etc, etc. So I've been working through a lot of the projects and I've done quite a number of them. But it was suggested to me, and I took that suggestion up, that others may benefit from following my journey as I learn the Arduino. So I decided to take them up on that offer, or that idea, and this is the first of the videos. And I'm looking at an RGB LED. So, firstly, we need to be able to show together how this hardware that I've created, that we have, links up the Uno with the common cathode RGB LED. An RGB LED is really essentially a component which contains three separate LEDs for different colors: red, green and blue. They use similar physics but different chemicals, and we're able to have three different colors at once coming from an RGB. There's two ways of wiring them up internally. One's called common cathode, one's called common anode. Type I'm using here in the kit is common cathode, and I'll explain that very briefly as we go through it. Now, one of the things that we need to be able to do with an RGB is to be able to show the different colors of light that are given off by it with different intensities and brightness. And a common way to do that is a technique called pulse width modulation, which we'll be using. So I'll be giving a brief introduction to that using the Arduino Uno to do pulse width modulation. Now, the program itself, showing the structure of the Arduino program, or sketch as it's sometimes called. We'll run it and explain it. Now, one of the techniques that we can use for actually using the Arduino and exploring it is to use what's called a serial monitor to show data on the screen. And this is a very useful method to understand and to debug a program. But the serial monitor allows us to exchange data with other systems. And one of the things I want to do is to be able to link together a PC with an Arduino. And for many years I've programmed the language called C# and a tool called Visual Studio. And one of the things I'll show here is how we can use Visual Studio and C# in conjunction with the Arduino and use the serial monitor to view data from it. So let's get on to the meat of the subject. Now, apologies first of all for the poor quality of the diagram I have here. One of the things I've been looking for is an affordable electronic design program, and one that I looked at early on was one called Fritzing, but it does seem, looking at the website, there's not much been done on it for years, and I've tried running both the 32-bit and the 64-bit download, but I've not had any luck with Windows 10. I may be doing something wrong, so that may change, but for the moment I've just done the circuit diagram using paint.net. And here we see a picture of the Arduino Uno along with the breadboard. And on the breadboard we have the RGB component. You can see that it's 4 different leads on it, and those 4 leads allow us to individually access a red, a green, a blue LED, and the 4th lead allows us to join together these parts of the LED, or the separate LEDs. Individually, LEDs have 2 main parts: an anode, which is a positive end, and a cathode. And when a current passes through from anode to cathode in the positive to negative direction, then light is given off, and the colour of the light depends upon the chemicals that's used in the manufacture. We have two different ways of actually joining up these 3 individual LEDs. One is by joining together the cathodes. Another way is to join the anodes. If they're joined together at the cathodes, it's called common cathode. This system, or the kit that I've got, uses common cathode. Now, the LED is linked using 3 pins of the Arduino, 3 digital pins. Pins 5, 6 and 9, and these are connected to, initially each 3 leads are connected to an individual resistor, which is then fed to one of the colors LEDs of the device. And the resistor is required such that when we have this switched on, when we have an on signal to each of these LEDs, is that it doesn't draw too much current and burn out the LED. So these are current limiting resistors, and the values I show here are 330 ohms, but you can use a wide variety of values, and in fact I think in the kit I use 220s. They work perfectly fine. It's just to stop the LEDs being broken or to be breaking here. So we've got these individual the diagram, and the program is really switching on and off these things and using various techniques. Now, because an RGB has these three separate colors, we can actually have all three colors on at once. And a technique, as I mentioned earlier, called pulse width modulation, allows us to vary the brightness, to have it from a dull red to a bright red, and similar to a green and blue. And the way that colors combine with the human eye and the human brain in this way is to use the Venn diagram system we see here for additive colors, where red, green and blue together will combine the illusion of white light. Blue and red together will give us kind of purple color, while we can see that red and green will give yellow. Do not confuse this additive primary colors with the subtractive primary colors that you may have met before within art at school or whatever, or in printing. They use a different technique. This one uses dyes and filters. This one uses real light, and that's the ones that we're concerned with. So what's this pulse width modulation about? Well, let's work out what we're trying to do here. We're trying to vary the brightness of the individual colours of an RGB LED. And we know normally that to change the brightness of a bulb, we can simply change the voltage. To make a bulb glow more brightly, we increase the voltage. To make it dimmer, we decrease the voltage. And with a digital system like Arduino is, we know that we've only got 0 volts and 5 volts to play with. So it seems on the face of it that all we can ever do with an LED is to either have it fully on, with 5 volts across it, or fully off with 0 volts across it. But that's not good enough. We want to be able to have more of a gradation, more levels between totally on and totally off. How do we do that? And that's where PWM comes in. Now, first of all, notice is that we're always connecting to a digital pin here, but there's only certain digital pins we can connect to that allow us to do PWM, and that's the pins that are marked with a tilde sign. Pins 3, 5, 6, 9, 10 and 11. Notice also is that these PWM pins allow us to treat them either as PWM pins or just ordinary digital pins. It depends on what Arduino function we use to switch them on and off. We can either use a digital write, which will work for all the pins, even the pins that are not marked with a tilde. Digital write where we give the pin number, which the red pin I think is number 9 in this case, and we can set it either of one of two values, either high, so it's totally on, or low, so it's totally off. And all pins can do that, including the PWMs. But with the PWMs we have an additional method or function that will work, the analog write function. We still need the number of the red pin, which is the case of number 9, but we can now have a value that can take on values other than just high or low. We can have any value in there that's in fact a byte value between 0 and 255. So altogether we can get 256 different levels of brightness from an individual pin. A lot better than the 2 with a digital write. And that's done by Arduino. What it does is it sets up on the PWM pins, when I see the analog write, it sets up a series of pulses to the pins. And the default is that pins 5 and 6 work on approximately 1 kilohertz. These are 1 kilohertz frequency, that's 1000 times a second, or another pin's 500 kilohertz roughly. So we'll say it's either 1 millisecond between pulses for 5 and 6 and 2 milliseconds for pulses for 490 hertz. So essentially that would mean here is that distance in time from there to there is either 1 millisecond or 2 milliseconds. Now, by controlling the amount of time within this pulse is that we're switching 5 volts in to switching 0 volts, because we can only remember digital go either 5 volts or 0 volts. By changing the relative amount of time between 5 volts and 0 volts, we can change what's called the duty cycle. And we do that by changing the number that's this R value in here. 64, for example, that's a quarter of 256. So that really means is that for 25% of the time, as it says, switch me on 5 volts and then the rest of the time make it 0. So that on average, I'm going to be a quarter of the way along between 0 and 5 volts, so that although it never reaches 1.25 volts, it says that on average the value here is going to be 1.25 volts. If I have 50% duty cycle, then essentially it means is that it's 5 volts half the time, 0 volts the other half the time, so averaging out it's 2.5 volts. It never is 2.5 volts, but it does average out to that. And as far as our brains and eyes are concerned, it's too fast for us to see the flicker, so it looks like a smooth change to half brightness. So here's how we can then mimic then the actual making the number of different brightness levels greater than the 2 we'd expect from straight digital stuff. Now notice also as well is that these frequencies can be changed, although we have to do various more complex things with it, but these frequencies are probably fine for things like LEDs and for motors. For other specialist uses you might want to have much higher frequencies, but that's a different topic altogether. But notice is that first of all is that one is we can only use certain pins for PWM, but the pins we use for PWM we can use for audio digital writing as well. It's just that we can't use analog write with an audio digital pin without that. It won't work. So that's like just a quick overview about PWM. Right, a quick look over the program structure just now. We have a number of areas, some of which you'll see on many Arduino programs, other ones which are just specific to this program. I have the global area. Now the global area is, generally speaking, is always at the beginning or the top of an Arduino sketch or Arduino program, and it's an area where we put code that we want to share or values, usually things like variables, the values of which we want to access or utilize from elsewhere within the program. Having them at the top is a convenient place. There are probably using globals too much is never good practice for reasons which will become clear as time goes on, but which I won't go into just now. But I do have global areas, and I have some within this program as well. Now when I create a new Arduino program or sketch, it creates automatically 2 empty functions or methods, one called setup, which is executed once when the program starts up and once only, and one that is executed many times called the loop function, which repeats over and over the various code. So setup and loop, I am using that within this program. Not all programs use both a setup and a loop, although most will use at least one of these, and most use in fact all. What I've also got here is 2 other functions. These are ones I've written that are not part of the Arduino setup and are used for various reasons, usually to reduce the amount of code or to make the maintenance of the code easier. So what this will do, this will blink the LEDs a certain number of times. This one here will set color function, we'll use the pulse WM. So if I bring my code over, just pause. So if I look at the code here, it's 3 lines here for the globals. Notice is that I'm using integers to specify what the pin numbers are. A lot of purists will argue, and I have to agree with them, that this is wasteful because these values are always considerably less than the 255 of a byte value, so I could use byte value there. Integers take up 2 bytes of memory, and that basically is wasteful. So a better way to write that would be a byte, B-Y-T-E, but just to show you that integer works as well. It's just that many programs on the net you will use integers there for the pins, but do notice is that in most of the ways of writing programs, there are alternatives. And personally, I would rather see that done as byte, B-Y-T-E, red pin equals 9. But I've used integer because it's a common parlance. Also as well, because I'm not changing the values of red pin, green pin or blue pin as the program runs to set them at the beginning in the global area, is I could actually put the word const. So I could put the word const there, C-O-N-S-T, and then use that for each of the three of them. But I decided not to put that in this time. But personally, I prefer to have const byte, red pin, green pin and blue pin. Here I've got a comment. These are comments, the two forward slashes, and this essentially says uncomment the following line if using a common anode RGB. Now, as I mentioned earlier, we're using a common cathode RGB LED, so that I don't uncomment that. But so if I did uncomment that, I would use that if it's common anode. What this actually does, as we'll see by examining the code, is that if I use a common anode RGB LED, is that this defining this as common anode would change would modify how this last function did its job. It's basically saying that if common anode wasn't uncommented, then I'd have to modify the red, green and blue values by the way shown. So going back to here, so there's my global areas. These are lines in here. Now my setup function, first thing I do is I've said what the pins are. I've said what pins I'm using. I now need to tell them if I'm going to use them as inputs or outputs. Well, because I'm putting lights on and off, I'm using these as outputs. So using the pin mode function there allows me to set them up properly as outputs. I'm going to be using the serial monitor. A serial monitor, the actual, whatever the COM number of that is set by my system, but the baud rate, how fast information is sent to the serial system, is determined here. And that saying is begin the serial monitor at 9600 baud. No particular reason for choosing that other than that's a very common value, so it's more of a habit using that number than anything else. Then I say call that method blink digital N 3 times. 1, 2, 3. Call it first of all with the red pin with the number 3 and 500 in here, then the green pin with the numbers 2 and 500 here, and then 3 and 1000 with the numbers here. So let's look at this function on this in here just now. And void blink N basically says void means, technically it means don't return anything. Blink digital N is the name of the method or the function, and here I have 3 integer variables. Int pin, we go back to our argument before, using byte for that. Int times, well, the times could be anything between 0 and 65,000 odd, but normally we're going to have 2 or 3, so we could argue that that would be only ever used effectively as a byte. The number of milliseconds, but notice we do have latitude. The main thing is with the values we're having here, we're wanting whole numbers, so therefore ints, bytes and longs are the alternatives. And generally you try and choose the smallest value that will take everything that you need. Bytes is probably about the smallest we're going to use, but ints tend to be quite common. So here first of all I'm using a for loop because I want this determines how many times I'm going to blink the particular colour that I send. So when I say, for example, send this, it puts the value of the red pin, which is 9, in here. It puts the value 3 into times there, and it puts the 500 into the value of MSDL. So every time I call this, the value is going to be set by whatever values I send to that method or function. And here in our for loop, for int I equals 0, and essentially it's going to blink however many times I say. By blinking once, it means we set it on high, we then wait a little while, we then write it low, and then we wait again. So this whole cycle here is said to be one blink. So blink N means blinks it does as many times as I need here. So essentially then is, as we'll see, this will blink the number of times I require. So into here, the void loop, this keeps going on and on and on over again. So it starts here, works the way, set color. So I'm calling this method here, this function, this method here, set color. And notice it expects 3 parameters or values. Each of them is int, but I could argue again, once again, I could use my byte argument, because really when I'm doing the PWM, it's an 8-bit or a byte PWM, so having int here is fairly wasteful, but so byte would work in there better, but again I'm keeping it simple so we don't have to get too much into difference between ints and bytes and longs at this stage. It works, it's not efficient, but it works. So the values I'm sending in is, I send the red value of 255. Here for example it's going to be 255 for the red, green 0, blue 0, and then it sets that'll actually set the color, and it'll stay like that for the it'll then print out what the actual command was, wait a second, then do the same, and each of these then is the same bits. It's printing out the serial monitor so I can see what the command was that preceded it. And the reason that I'll actually have this in as a serial dot print is it will allow us, when I link in with the PC, to see that command. So there we're going around and round and round. So let's now just bring the actual camera in here, and I'll just do this a second. Let's now run this. It's still running from the old cycle here, just wait until we see stuff appear on the serial monitor. Right, that's the end of the setup stuff, digital write done. Now notice so it did whatever it was needed to do, and it's now running through these different colours here. You can see the colours maybe don't quite match exactly what they look like on the screen, but that's typical with a video camera. So that's what the program looks like. Ignore those 2 things on the breadboard, they've come from a previous project. We're using the switches for something else, but this essentially is just showing what you have. When you set the program up and run it, then you'll see it without the influence of the video cameras. So essentially there's the colours, there's the monitors. So that's very, very quickly the actual program itself. So now I want to show you this linking, getting the output from the Arduino and link it in with the PC. And this PC here is running Visual Studio, a small short program that I've written essentially in Visual Studio C#, and I'm going to run this just now. Before I run that, in fact, I'm going to look at the monitor again. We can see the lights is flashing away. So the program's still running, that's real time, and I've just close the monitor, the serial monitor on the program just now, because when I run this then I will get an error if the serial monitor on the Arduino is running at the same time. So I'll switch the serial monitor off, but now run this program, and we can see the output. There's back against the screen again, and now we can see it's running through the various stages as it did before. That's why I actually put these set colours in and add the numbers in, but we can see from this one that broadly speaking they're pretty close to the right numbers. The red, green and blue is certainly fine. Things like the aquas and all the rest of it maybe don't quite, and yellows don't look that good, but we can see the system working and they're fine. So here clearly we're getting information. That information is going into the port here. We can see the cable. You can see this is the USB cable in which the information, and this is linked to the PC, so it's just being picked up via the USB as a COM port. So there it's running through. Now, although I'm just reading stuff from the monitor, there's nothing to stop me using another method, this time a C# method, to actually write information and then pick it up at the Arduino level so it does stuff. But the important thing is that then with this information, now although I'm just printing this out, I could be using this to measure temperatures and pressures from transducers on the Arduino, and then I could be sending them off to a database or off to the internet or something. But having this kind of serial access gives us access to the big wide world and gives us an opportunity to possibly get into the Internet of Things. So that's the first lesson. So hopefully I'll see you soon. Right, thanks. Bye.